Okay, so what we're going to talk about today is similar lengths, areas, and volumes. So the idea here is that we've got two three-dimensional shapes, and they are similar. So we could just put a similarity sign in between them. So cube A is similar to cube B. And what we've got is the lengths of the first cube, cube A, to be 2 units. So we can here, whether it's meters or centimeters, doesn't really matter. But there is a scaling going on of the lengths. In other words, we have got the lengths of my bigger cube, they're twice as big. So my length of my cube A is 2, and my length of my cube B is 4. So what's happening to the areas? Well, we're going to consider this shaded area of this front face here. And how do we calculate this shaded area? Well, we do length times breadth, multiply those together, so we get 4 square units. And if we do the same thing on the big cube, we get 4 times 4, which is 16. So we've now got 16 square units. Now we're going to look at volume. So the volume of cube A is 2 times 2 times 2, and that's 2 times 2 times 2 is 8 cubic units. Whereas if we've got the cube that is dimensions twice as big, then its volume is 4 times 4 times 4, which is 64. So what's actually happening here is that if we double our lengths, multiply by 2 on our lengths, then our areas are multiplying by 4, and our volume is multiplied by 8. Now, actually, this 2 here is called the scale factor of lengths. So what we're noticing is that if the scale factor of the lengths is 2, then the scale factor of the areas is 4. And the reason being is that we're squaring. Remember, we square with areas. And with volumes, we're cubing. So we take our scale factor, which is 2, and scale factor of lengths is 2, and we square for areas and cube for volumes. So let's generalize that now. If the scale factor of the length is s, in other words, this first cube, whatever its lengths are, the lengths of the larger cube is s times as big. Okay, so if our scale factor of our lengths is s, just pause for a second and I'd like you to tell me what the scale factor of the areas is. Okay, so hopefully you've told me that the scale factor of the areas is s cubed, and the scale factor of the volumes, again I'll pause, the scale factor of the volumes is s cubed. And that's the important thing here, is that if we're scaling a two-dimensional shape and we're making the second shape s times as big or s times as small as the original shape, then the areas will be s squared times as big or s squared times as small, and the scale of the volumes will be s cubed. Okay, we're going to do a question on that now. Stop this video and we'll do some questions in a second.